recap, especially for those that are absent today. Just waiting. Thank you. We took some copper sulfate, which is a solid. And you were asked to find an exact concentration of how much? 0.05 moles per liter. And the volume that you had to do it in, for most of you, was 100 mils. So the first thing that we decided that we would figure out is how many moles are in there, C times V. So 0.05 moles per liter times 100 milliliters. And that gave you, I don't know, what is it? 5 millimoles. But I can't measure 5 millimoles. I can measure a mass. And so mass equals number of moles times our molar mass. So that's 5 millimoles times, what was the molar mass? 300 and?
It was 159.
159.62, although
159.
159?
Yeah.
Yeah. And although Nick calculated it slightly differently when he went to his data booklet.
159.72.
So but everybody else used 6.2, so we're going to use 6.2.
Yeah.
Okay. And then what did you get?
798 milligrams.
798 milligrams, or 0.798 grams. Okay? So then you took that mass, and we go about preparing an exact solution. What's this apparatus called? A volumetric flask. And what is stage 1 to do with this volumetric flask? What did you do first?
Fill it with water.
Fill it with water?
Or not fill it, put some water.
Put some water in. How much water should go in?
1/2.
I would say a third, a quarter to a third. Okay? So first of all, 1/3, oops, 1/3 water goes in. Then what did you put in? Then you put in your mass of copper sulfate, which is a powder, through a funnel, yes? So through a funnel, oh no, I mean through a funnel we put our water. Anyway, so we put this in, it goes here, and then you've got a bunch of crystals down there, and what did you do with it? Swirled it. So then so add your solid, then swirl until when? Until dissolved. Why don't we put the cap on and mix it like crazy? What would happen? Those of you that have taken your cap off by now, have a look at your volume now. Is it where it was before? Is your meniscus at the bottom where it was supposed to be exactly like it was? Exactly the same? Most people's won't be. Why? What happened?
Because some will go to the top.
Bubbles would pop and that wouldn't change the volume.
Some of it in that gap.
Yeah, some of it's at the top. Some of it's sat up here, some of that. Right? And on the lid. So you lose volume if you put the lid in and shake it. You lose the volume in this top bit and you lose the volume on the lid cap. You can see droplets up there, can't you?
Yeah.
You can see droplets on your cap, can't you? So that's where it went. So we don't want to do that until we know we've got the exact perfect volume in there. So when we've got just that little bit of water and the salt down there, we then swirl until it's dissolved. And then when it's really dissolved and a beautiful concentrated solution, we then finish the water. We then finish the water up until that perfect line. And we wanted the bottom of the meniscus to be where that line is. So you got down on your eye level of that line and you put eyedropper, drop levels of water until it was on that, the bottom of the meniscus was on that line. Yes? And then, lastly, So, sorry, I haven't been writing these down. So add water, add solid, swirl and dissolve, fill until the bottom of the meniscus is on, I don't know if I've spelled meniscus correct, on the line. I assume you guys are all writing these down. Until the bottom of the meniscus is on the line. And then stopper, and what do we call that? Shaking it upside down? Mixing by inversion. So stopper it, put the stopper on the top, and you flip it upside down and flip it right side up, and flip it upside down and flip it right side up, and that's mixing by inversion. So 1, fill 3/4 of water. 2, add the solid and swirl. 3, fill until the bottom of the meniscus, I know I've spelled meniscus wrong, is on the line. And 4, stopper and mix by inversion. Okay, got the steps?
Yeah.
Okay, so that kind of summarizes N equals C times V, practically and mathematically. Okay, so now today we're going to talk about dilution. So you're going to take your solution that you've made that was a lovely 0.0500 moles per liter, because you used a volumetric flask, so it's much more exact, and you are going to dilute it. Okay? So, how do we figure out dilution? Well, if I take this and I dump it into a new volume, the molecules that were in this flask will be the same as the molecules in the next flask. Does that make sense? So, hold on, I need a new page, and I'm going to draw a flask, and I'm going to fill it. Okay, so this is a concentrated solution. Your concentration was 0.05 moles per liter. The number of moles in here was, tell me again? The number of moles that you made?
159. Yeah, 159.
No, that's a mass.
5 millimoles.
5 millimoles. Okay? And if I were to dilute it and take this and put it into a new volumetric flask, it would still have 5.00 millimoles. So your number of moles is the same. Your volume are different. So because of that, and the concentrations are different. So the concentration and volume here is different. I'm going to call that flask 1. This is flask 2, concentration and volume. But the number of moles is the same. So N1 equals N2. And if N equals C times V, then actually c1v1 equals c2v2, because the number of moles is the same. So to figure out a dilution, we use the formula c1v1 equals c2v2. The end. c1v1 equals c2v2. Why? Because the number of moles is the same, no matter what. Even if I didn't dump the whole thing over, I can still use this formula because I'm taking a section out. And the concentration of that section is still the same as I transfer it. Okay? So now we're going to make up a dilute solution. So what do we have in terms of our C1 and our V1? The C1 is 0.05 moles per liter, right? And the volume that most of you have is 100 mils. Everybody okay with that? And we're going to make up a new volume. And luckily I found a bunch more 100 mils. Yeah, if I'm about to boil 100 mils. Can I do this? Can you do this? Equals, what will the concentration be if I used a new volume of 250 mils? Just math, right? Type in your calculator, 0.05 times 100 divided by 250, and that should give me my C2. 0.02 moles per liter.
What do you mean? Millimoles from it? 'Cause it's in milliliters?
No, the milliliters will have cancelled out with these milliliters.
Oh, okay.
You're okay? I thought you were putting your hand up for a question. Does that make sense? Okay, so we're going to do a practical application, but I also have a sheet for you in a minute that has, so for those of you that are missing this lesson, this sheet practices that concept. C1v1 equals c2v2. But before we get to that sheet, I'd like us to dilute our volumetric flasks, and we'll see how we can play with that a little bit. Okay?